Hello everyone, my name is Ern Racer and this is my best. Today I'm going to show you the first trick that we can use for us to be able to factor perfect square trinomials. That is the scissor method. Now we have here three quadratic trinomials or perfect square trinomials. So we're going to use the scissor method for us to factor these three quadratic trinomials and to bring their factors back into the respective parentheses. So unlike the ordinary trial and error method, which actually makes you have a lot of mess in your paper, especially that if you didn't get the right factors, you would have to start the process all over again by erasing the parentheses or even tampering the numbers input in those parentheses. This scissor method only makes you want to draw a scissor and then inserting each factor in every end of that scissor, and then once multiplied and combined, will actually result to the middle term of these quadratic trinomials. And so for better visualization, let us have this first example we have right here. We have 3x squared plus 4x minus 64. All right. The first step we have to do is, of course, to list down the factors of the first and the last term of this perfect square trinomial. Let's start with 3x squared. So eliminating the x squared first, so for us to be able to list down the factors fast, we have 1 and 3. There's only one factor anyway for 3. And for 64, on the other hand, it actually have a lot of factors. So the first factor would be 1 and 64, of course, and then could be 2 and 32. Instead of 32 and 2, we have 2 first, right? The least number before the greatest number. And then third, we have here 8 and 8. Lastly, we have 4 and 16. Now let us test out each factor with this second step. So in our next step then would be the most exciting part, because all we have to do here is just to draw a scissor. Okay, so inserting these factors of 3, all we have to do is draw a scissor, and this is how the scissor will look like. So here and right there. Okay, and then the next step is to try out every factor of 64. So one factor at a time only. We have here first 1 and 64, which would be the first factor we will have to try. We have to first combine these factors right here. You would see this line that actually intersects them, right? So we have to check if once these factors are multiplied and then combined to each other, the resulting answer would just be the same as the middle term we have in this perfect square trinomial, which is positive 4. Now let us try. 3 times 1 is equal to 3. And 1 times 64 is equal to 64. And so it does not equal to 4. What if I try to put a negative sign here? Which would make 3 negative, because putting a negative sign here means that we're making 1 negative. So 3 times negative 1 is equal to negative 3. We're making this one positive, but even if we don't put that positive sign, it just automatically reads only positive. So 1 times 64 is 64. Will 64 minus 3 be equal to 4? No, still not. What if I make this one positive and this one negative? Still not, right? Because 3 minus 64 doesn't also equal 4. It could be equal to something else. If I reverse or put the numbers in their opposite places, we make 3 have 64 and 1, 2 have 3. Where 64 times 3 is equal to 192, and 1 times 3 is equal to 3, it still does not equal to 4. So then we can conclude that 1 and 64 is not the factor of the perfect square trinomial. So we would have to try another set of factors. The next factor we would try is 2 and 32. Alright, so 3 times 2 is equal to 6. And 1 times 32 is equal to 32. Now, whether I put a negative sign on either 32 and 6, it would still not equal to 4. So So 2 and 32 is not also the factor for the perfect square trinomial. For 8 and 8, we would still experience the same scenario we have. Whether I would make this negative and this one positive, or this one negative and this one positive, it will still not equal to 4. But if we try putting our last pair, which is 4 and 16, we can actually get the value of 4. So check this out. We have here 3 times 4, which is equal to 12, and 1 times 16 is equal to 16. And you would see that if one of them will become negative, we would actually obtain the result of 4. And that is by making 12 negative. And so how? We would put a negative sign right here, which would make 4 negative, and so 3 times negative 4 is equal to negative 12. So 16 minus 12 would become positive 4. Yay, we already got the factors for the perfect square trinomial. So all we have to do is just to write them down in parentheses. So how are we going to list them down in parentheses? So these numbers right on top of the scissor, we have here 1 and negative 4. Always insert a negative sign, don't forget it. These numbers would be for the first parentheses, while these two remaining numbers right here are for the second parentheses. So, okay, let's write the numbers for the first parentheses. We have here x minus 4. And for the second parentheses, perhaps 16 is positive, so we're going to write 3x plus 16. And there you go. These are the factors of this perfect square trinomial, 3x squared plus 4x minus 64. With the use of the scissor method, we were able to reduce the amount of time for finding the factors of this perfect square trinomial. And so let us try another example. We have here 8x squared minus 44x plus 48. This time, our middle term is negative. Right, now let us list down the factors of 8x squared. Eliminating the x squared, the factors of 8 are 2 and 4, and 1 and 8. Now for 48, we have a lot of factors for that. The first one could be 3 and 16. The second one would be, of course, 1 and 48. Next one would be 24 and 2. So I say 2 and 24. Last one would be 6 and 8. So let's do the second step. So the second step would be 22 and 4. And then try out one factor for 48, which is first 3 and 16. Making sure that we're going to obtain the result of negative 44. Let's try. 4 times 3 is equal to 12. 2 times 16 is equal to 32. And there you go. We're actually getting the result of 44. And which do you think must have the negative sign for it to become negative 44? Actually, it's both. So we're going to have to put two negative signs here. Negative 12 and negative 32. There you go. We're going to get the answer of negative 44. The last step is to put these numbers right here in a parentheses. Same like a while ago, the numbers on top of the scissor would be placed in the first parentheses. We have 2x minus 3. And these numbers below the scissor would be for the second parentheses, 4x minus 16. And there you go. These are the factors of the perfect square trinomial. Not only actually 3 and 16, which are factors of 48, can only work for this perfect square, for finding this perfect square trinomial, but also even other factors that can pair up with 2 and 4 can also get the answer of negative 44. Like for example, 2, 4, and 6 and 8. So we draw a scissor, and then we would write 8 and 6. Eight, 4 times 8 is equal to 32, and 2 times 6 is also equal to 12. So as you can see, we would also get the answer of negative 44 by just making these two numbers negative. There you go, negative -44. Another factor for this perfect square trinomial is 2x minus 8 and 4x minus 6. There you go. Lastly, we have here 24x squared minus 12x minus 12. Alright. So same procedure as to how we got the others. We just have to follow the scissor method. No any exceptions, no any other rules. First step is to just list down the factors, and then to line up the factors of the first term, and then drawing a scissor, and then trying out each factor of the last term, and then multiplying and combining it to make sure that it equals the number in the middle term of the perfect square trinomial. Then the last step would be putting those numbers on the top and the bottom of the scissor into two parentheses. Now let us do that once more for this last perfect square trinomial we have right here. This is 24x squared minus 12x minus 12. Alright, so 24x squared. Its factors could be 2 and 12, could be 4 and 6, and also could be 1 and 24. So that's, and then for 12, we also have 3 factors, could be 2 and 6, 3 and 4, or 1 and 12. Alright. Now let's try out the factor in the middle. We have here 4 and 6 for 24. And we would try 2 and 6 from the factor 12. Let's see. Making sure that we're going to get the answer from 12. Negative 12. Alright, 6 times 2 is equal to 12. 4 times 6 is equal to 24. Alright, so 24 plus 12, we have the answer of negative 12 if one of these numbers right here are negative. That is negative 24. Once we make 12 negative and not 24, it would result to positive 12. Because 24 is greater than 12, and so it must be that greater number carrying the negative sign, not the lowest number. So 4 times negative 6 would result to negative 24, and in that way we would get the answer of negative 12. So that's already a one-step guess, everybody. We already got the factors of this perfect square trinomial. All we have to do then is just to put these 4 numbers into their respective parentheses. For the first parentheses, we have here 4x plus 2, and for our last parentheses, we have 6x minus 6. There are also other factors here, such as 2 and 12 and 1 and 24, where once we try one factor from 12, it can also result to another factor for this perfect square trinomial. And it's something you can try at home. And that's how you use the scissor method for us to be able to factor perfect square trinomials. See you again in another video of Math Magic, where we're going to have the other method or the other trick that we can use for us to be able to factor these perfect square trinomials. See you on that episode. My name is Aaron Racer, telling you to stay safe and keep following Math Magic. Bye!